Hi, let us consider a problem on relative motion. Two cars P and Q are moving with the same speed 20 meter per second. P is at the origin and Q is at a distance of 100 meter on the north side of P. If P moves along east and Q towards south, find the minimum distance of approach and the time after which distance becomes minimum. So let us read the problem carefully. There are two cars P and Q moving with the same speed 20, but P is at the origin and moving towards east. And Q is on the north side of P, 100-meter distance, but Q is moving towards the south. What is the possible minimum distance between them? And after what time this is possible? So let us consider east, west, north, south. So this is one car P, this is another car Q. P is moving towards east, Q is moving towards north, and the distance of separation between them is 100 meter. So this is our P, this is our Q, which a distance of say D, but Q is moving towards south. P is moving towards east and Q is moving towards south. Now, as the bodies are moving, suppose P moved from this origin to this point. By the time, let us say Q moved to this point. So this will be the distance between P and Q. After some time, P reaches another point, say this one. By the time Q reached here, then this will be the distance. So question is, what is the minimum possible distance between P and Q because of this motion? So as they are moving, what minimum possible distance we can expect? So let us consider the starting. So let us imagine what is the relative velocity of Q with respect to P or P with respect to Q. Since P is at the origin, now let us take relative velocity of Q with respect to P. Relative velocity of Q with respect to P. P is at the origin and moving towards east. To find the relative velocity, always reverse the direction of the observer. Here Q is observing, so I will reverse its direction. Imagine Q is moving towards north. This for calculation of relative velocity. Because in relative velocity, observer always feels that he is at rest. So here I am observing velocity of P with respect to Q. Since these two are acting at 90 degree and velocity vectors magnitudes are same, both are moving with same speed. So the relative velocity will be along northeast. So what is the meaning of this relative velocity? Here our observer Q is, though he is in motion, because he is observer, he feels that he is at rest and P is moving along this direction. This is the line along which the P is traveling with respect to Q. So when P is at different positions, say P is here, this becomes the distance. When P is here, this becomes the distance. When P is here, this becomes the distance. So if you observe this figure, automatically the minimum distance is possible for this perpendicular dropping. Means whenever I consider a point and a line, between these two, the minimum distance is nothing but this perpendicular distance. Remaining all distances are more than this one. So here, this is our Q. This is some new position R. This is our point P. So this is P. This is R. This is Q. I am showing the same thing. This figure here I am redrawing it. What is the value of this angle? PQ direction, what this relative velocity makes. Already we know when two equal vectors are taken, automatically the angle made is 45 degree. Here I am considering two equal velocities. Let us say this is one velocity, this is another velocity. The angle between them definitely 45 degree. If this is V, this is V. This is our P, this is our Q. So velocity of P with respect to Q. In the vector notation, it is Vp bar minus Vq bar. Since the angle is 90 degree, I can write the magnitude of relative velocity as Vpq is equal to root of Vp square plus Vq square. Cos 90 term 0, no need. That means root V square plus V square, which is equal to root 2 V square or nothing but root 2V. The relative velocity of P with respect to Q is root 2V along the direction. So what is the direction along which it is moving? It appears to be moving along this direction. So in this figure, this value, since this is 45, is nothing but this one, 45 degree. Therefore, this right angle triangle PRQ, in this I want to calculate opposite side. So opposite side is QR. So how to calculate this opposite side? The simple, take sine 45. Sine 45 is equal to opposite to QR by hypotenuse PQ. Therefore, QR is equal to PQ into sine 45. What is the value of sine 45? 1 by root 2. PQ is D. This is 1 by root 2, which is nothing but D by root 2. But in the present problem, D is given as 100. So this becomes 50 root 2 meters. The closest distance or minimum distance is nothing but 50 root 2. Also, we have to calculate that time. So what is the time? It is the time taken for the P to move from P to R. This time I am interested. So time is given by distance PR and relative velocity of P with respect to Q. Again from the figure, PR is nothing but D cos 45. Because if I take cos 45, adjacent side by hypotenuse is D, so D cos 45, and VPQ is equal to root 2V. So this is equal to D into 1 by root 2 by root 2V. Nothing but D by 2V. Present problem D is given as 100, V 20. So 5 times, 5 by 2 is nothing but 2.5 seconds. That means after 2.5 seconds, after 2.5 seconds, the distance between the two becomes minimum, which is equal to 50 root 2 meters. So if you have any problem of this kind, the minimum distance is possible if you drop a perpendicular from the observer. Out of the two, imagine one body is at rest, the second one is in motion. From the body at rest, drop a perpendicular onto the line of relative velocity. The length of that perpendicular automatically gives the minimum velocity, right?